So we're going to pick up two little topics here today, and this will then kind of complete the concepts that we're going to need to be responsible for our quiz on Thursday. All right. So the first little concept we're going to pick up is going to be like another property of circles. So we're still dealing with circles. Today we're going to be looking at angles in circles still. But we're talking about angles in an inscribed quadrilateral, right? So we're talking about, therefore, the quadrilateral is inscribed. So the quadrilateral is inside of a circle, okay? And specifically, we want to know what can you conclude about the angles of a quadrilateral inscribed in a circle? Okay, right? We've seen that word inscribed recently in our inscribed angles, where the angle is right inside of the circle, right, with its vertex on the circle there. Okay, we saw inscribed, weeks and months ago when we talked about, circles being inscribed in a triangle, right? Okay, we're not talking about quadrilaterals fitting inside of a circle. Okay, the quadrilateral is inscribed; it fits inside the circle. Okay. So we're going to skip the explore here and just kind of jump to what the actual property is here. So first of all, what do we already know about the angles of a quadrilateral? All the angles of a quadrilateral have to add up to what? (360 degrees, right? Okay, for a triangle it's 180, for a quadrilateral it's 360 degrees. Okay, right? And then we have that formula n minus 2 times 180. That gives us the angles for, any particular shape. Okay, when n is the number of sides. Angle sum for any particular shape. So, as it turns out, an inscribed quadrilateral, okay, the theorem for this is if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay? If a quadrilateral is inscribed in a circle, then its opposite angles must be supplementary. Okay? Again, we're not going to run through the proof of this, so don't worry about that. But just looking at this quadrilateral, that means that angle A, okay, or I should say DAB, angle DAB will be supplementary to what other angle here in the quadrilateral? BCD, right? So these two are supplementary, okay? And angle ADC is supplementary to ABC. So those two are supplementary as well. Okay? Opposite angles are supplementary there. Okay? So, if you turn the page to page 795, you'll just see a quick example of that. Okay? In example 2, right, you see an example, and we're asked to find the angle measures of each inscribed quadrilateral. So here's our quadrilateral, right, PQRS. All right, and we have some angles listed there too. Okay? Now notice here we're only given 3 angles, but we're asked to find all 4 angle measures. Okay? So we want to relate these things. Now if you look here, right, angle QPS is a measure of 5y plus 3. Angle PQR is a measure of y squared plus 53. And angle QRS is a measure of 5y plus 17. Okay? So, how should we go about relating these things? What's an equation we can set up here? Jenny?
The 18y plus 17 plus 5y plus 3 is
Yeah, QPS and QRS have to add up to 180, so you can write that out. And in fact, they do that right here. Okay, and they combine like terms, solve for y, you get y equals 8. Once you have that y is 8, then it's a matter of plugging in, right? So 5 times y plus 3 gives us a 43-degree angle here. Okay, when you plug the y equals 8 in. All right. When you plug in y equals 8 for the angle QRS, okay, 8 times 15 plus 17 gives us 137 degrees. And then for angle Q, which is y squared plus 53, you can plug the 8 in for the y there, okay, and then you get 117. For angle PQR. How can we find the missing angle measure right here? For that last angle in our quadrilateral, angle PSR there, what could we do? Okay, so angle PSR will be supplementary to what other angle? PQR, the 117. So you could do 180 minus 117, which is going to be, 63? What else must be true about this missing angle right here? If we have 3 angles in a quadrilateral, how can we find that 4th missing angle? Subtract them from 360. Exactly right. So in fact, if you do that, that'll also work. So we could also do or 360 minus 43 minus 117 minus 137 equals that 63 degrees as well. Okay. This shouldn't surprise us though, because we already know that 43 and 137, these 2 angles are 180 degrees in the first place. Okay. So we'll see you, John. The assignment will be on Google Classroom. Okay. So there's that. All right. So turn the page there, and let's try another one here together. Okay, so you can see we have another quadrilateral, JKLM, inscribed in a circle. Okay. How can we, and we're trying to find all the angles here. So how can we relate some of these pieces of information? Let me call on someone maybe here. Let's go to... So, well, Madison, what do you say there, Madison? How can we set up an equation here?
You know that angle MJK and KL, I think?
KL,
are equal to each other.
Not equal to each other. They're going to be what?
Oh,
Supplementary. There you go. So we'll add them up, set them equal to 180. 39 plus 7x plus 6x minus 15 equals 180 degrees. Okay. And then you solve, right. So 7 plus 6 is going to give us 13x. 39 take away 15 is going to be 14. Nope, 24. Okay. And then we'll subtract 24 from both sides. So 13x equals 156. And then divide both sides by 13, so 156 divided by 13. 12? Yeah, okay. Good, yeah. Okay, so x is 12, but we're not done. We want to come up with all those different angle measures then, right? And so let's see here. Let's see here. The measure of angle MJK. MJK will be 39 plus 7 times 12. So 123. Okay. The measure of angle, let's see, MJK, JKL, we'll do that one. 20 times 12 over 3, which is going to be 80. Okay, and the measure of angle KLM will be 6 times 12 minus 15, which is 57 degrees. Okay, so we have 3 angles, and then how can we find this final missing angle here? Let's go to Aubrey. So Aubrey, what do you say there? We know. So again, we know this angle right here is 123 degrees. We know this angle here is 80 degrees. We know this angle here is 57 degrees. How can we find this fourth missing angle there?
Wait, would that be if it's across from K? That means supplementary.
Yeah, right. So then what does M have to be?
Where you would just subtract 180 minus 80, so
100 degrees. Very good. You got it, Aubrey. Exactly right. Okay. So 180 minus 80 there. Measure of angle was at JML. 180 degrees minus 80 degrees equals 100 degrees there. All right, so there those are. Okay. So actually what I'm thinking I'm going to do here is I might stop there so I can give you guys time to work on this here in class, okay? We'll have a little bit of new material to learn tomorrow, and then we'll spend the rest of the time reviewing in preparation for Thursday's quiz. All right, so I think I'm going to stop there, though, all right, and just do that. So that way you guys can have a chance to get working on your homework with these shortened blocks. All right, let me get this.